Hi everyone, welcome back to Code and Architecture with Jukka. Today I'm excited to share an overview of what I have been working on with my simple rack server project over the past few weeks. I will walk you through the progress I have made, the key lessons I have learned, and share my thoughts and feelings about where this project should head next. Whether you have been following from the start or you are just tuning in, I think you will find some interesting insights and updates in this video. By the way, a recent study claimed that 73% of AI startups are just wrappers around ChatGPT and Claude, which makes it great that we are doing exactly the same thing, but in our case the goal is to make it general purpose, reusable solution. But before we dive in, if you find this kind of content helpful, please do hit that like button and subscribe to the channel for more deep dives into coding and architecture. It really helps me out and keeps you posted on future videos. So what has happened in the simple rack server project recently? I decided to focus on making the project more usable, not just developer tool, but something that can work as a turnkey solution or even pays for a SaaS service. This shift led to the addition of few new features. The most visible change is of course the front end. Now, why create the front end when the main value is in the backend doing the retrieval augmented generation? Well, I did a quick value analysis. If I only built a backend, it would essentially be another developer tool competing with frameworks like LangChain or Llama Index. To create more value, I need to target non-developers. People who want to build their AI assistants but don't have the knowledge or resources to do so. When I decided the web UI, I took slightly different approach. Instead of the usual React and Bootstrap stack, I chose React Native. The benefit. Right from the start, React Native provides responsive UI with polished animations, while React Native for web isn't as mature or smooth as iOS or Android. With enough work it works quite nicely. And the big upside is that this sets up us perfectly if and when we want to build native mobile apps later. The second major enhancement is the mechanism to segregate data for multi-tenancy. We use OpenSearch as our database and it supports vector search for finding similar content. The catch is OpenSearch filters results only after vector search, which becomes inefficient at scale. To handle this, I choose to create separate indexes in the same cluster for each data collection, rather than using one big index or separate clusters, which would be too heavy-handed. The downside is that Spring data for OpenSearch no longer fits perfectly because it doesn't support dynamic index selection. So I use the OpenSearch client directly to issue commands to the right index based on the collection. In our data model, each collection corresponds to its own index for documents and chunks. So every time we access these tables, we specify the collection ID to find the correct index. This keeps the data separated, preventing mixes and keeping vector search efficient. Now about multi-tenancy. In addition to collections, we have chats. Chats attach instructions for running the LLM and link to a specific data source. This design allows us to use the same data for multiple kinds of assistants or A/B test different prompts on the same dataset. What's missing right now is user and organization supports, which will come later. Also, the UI doesn't yet support dynamic configuration of LLM models or providers. Adding that would truly make the simple rack server versatile wrapping service for models like ChatGPT and Claude. So overall, recent work has focused on usability, flexible UI, and scalable multi-tenancy architecture to bring the simple rack server closer to our real-world general-purpose solution. Now let me show you how things actually work in the simple rack server. I have already onboarded 2 chats with different assistants. One is focused on personality guidance, while the other specializes on architecting data lakes. Each chat has its own separate data collection and system prompts to tailor their behavior. In this example, the system prompts aren't very different yet, but in real-world scenario they would vary significantly to match the assistant's purpose. For instance, if I were developing personality guidance assistant, I would aim to make it more coaching, encouraging, and as human as possible. That's because personality guidance is very personal and emotional area, so the AI would be able to handle human feelings and nuances effectively. On the other hand, our data lake architecture assistants would be designed to be critical and questioning, dealing with innate objects and data systems. Its users would likely be professionals, pushing for high-performance solutions, so the prompts would reflect that more technical, precise spirit. Let's start with the personality assistant. As you can see, it has a customizable hello message that immediately tells the user what this AI is about. This helps the user either engage with the relevant questions or realize if they're in the wrong place. Now let's ask a simple question. Tell me more about the history of Myers-Briggs. Boom. And soon we will get the answer, and unfortunately, because I'm doing the video recording and running the LLM with my small RTX 5070 card, things don't exactly work snappily. But as you can see, we have the LLM working and it's producing an answer quite nicely. And this is actually the IBM Granite 4 1 billion parameter model. Usually I use either the 3 or 7 billion parameter models, but now when recording the video I have to little bit scale things down. So we got the answer and we can see that it works. Now let's look on the data architecture AI. So let's ask the question, how can I implement, let's say, Delta Lake architecture in AWS? So this is a broad question, but it gives us a taste of how the system responds. And here's the answer. We get a technical and to the point answer that we more or less expected. So where are we at with the simple rack server? Right now, we have built basic service where different AI assistants can be created, each with reference to its own knowledge base. That's a solid start, but honestly, it's still basic. To really elevate the system, we are missing few key things. First, we need to add support for tools. Every chat should be able to define which tools it can use, whether connecting to API, running code, or referencing external databases. Next are agentic features. This might sound complex, but the truth is, most of the heavy lifting happens inside the LLM itself. So once the assistants can decide when to use which tool and how to sequence actions, you unlock real agentic capabilities. Your assistants can orchestrate tasks, reason through complex requests, and deliver much smarter results. Of course, all this only matters if users can interact securely and privately. That means adding user management and authentication so everyone gets their own isolated workspace and capabilities. If we get these features in place, tools for each chat, agentic orchestration, and robust user handling, then our multi-tenant simple rack server starts to look and feel like a true scalable AI platform. Now, in the beginning, I mentioned a recent study that claimed 73% of AI startups are essentially just wrappers around ChatGPT and Claude. But what does that really mean? It means these startups are mostly gluing existing AI services together, adding their own prompts and data to form unique context, but not building fundamentally new models or core tech. In a way, I don't blame people starting these kind of startups. Many begin with something simple. Once they validate their idea and gain customers, they might invest into building out their own tech stack. For example, if you eventually want to create your own models or fine-tune existing ones, you need data. And one way to collect data is running your own service that leverages existing AI providers. Over time, you can progress from there. However, this approach only works if you have deep pockets to cover the operational costs of using these big AI services. If funding runs out, then that's usually the end of the road. It's interesting to watch how the industry is evolving. Generalization and commoditization are happening fast. AWS introduced the S3 vector for seamless vector storage. Google offers Vertex AI with RAG capabilities. On plus side, this makes it easier for anyone with expertise and specialized knowledge to build AI around their own data. But for AI startups, this commoditization means it's harder than ever to justify their existence based on purely on the tech. Anyway, the great thing about working on open source projects like Simple Rack Server is that the only justification you need is that it's worth your time, and that honestly is pretty liberating. Let's see where the world goes. Hopefully I can get time to make another video rather sooner than later. Thank you for taking the time and watching the video. Please like and subscribe. Nothing makes me happier than having those thumbs up. Thank you.